In the last video, I built the dwarf wall for the workshop, and in this one, I get the walls up and insulated. The walls are framed with 100 by 47mm rough sawn timber. I start on the back wall, setting out a top and bottom plate, then having cut the studs needed, add one at each end with a couple of screws for the top and bottom plate into the studs. I also add another stud turned to its side at the end to act as a backing block where the OSB will be attached. After that, I start adding more studs along the length of the wall. The first stud gap is 34.7cm and the rest 36cm. Whenever there's enough for a sheet of OSB, I put that down as a guide to make sure the stud can be used for both that and the next OSB sheet. Adding the OSB sheets as I go, make sure that there's no drift in my measurements instead of adding all my studs to later find out they don't line up with the OSB sheets as intended. Once I reach the end, I also make sure to add a stud turned on its side again as a backing block for the other corner. I'm adding OSB sheets on the inside face of the wall, so we want the OSB to start a wall's width away from the side, hence the extra stud at each end turned on the sides. During all of this, I took extra care to make sure the frame was square. The OSB sheets being attached as I go help with this, as I know the corners will be square, so I kick the framing into place where it skews away from the OSB. The insulation rolls I'm using are pre-cut at 45cm wide, and the OSB at 122cm wide, and studs 4.7cm. A bit of math led me to the spacing between the studs being at 36cm, with the exception of the first being a bit smaller. The gaps are a bit smaller than the insulation, which is good as it means when it comes to adding it, I can just trim it slightly and squish it in to hold itself up. I left the top of the OSB overhanging and cut it down later, but still leaving a slight overhang of 47mm to account for doubling up the top plate later. The back and front wall ended up being pretty heavy even for two people to carry, so I ended up cutting the wall in two around the midpoint, two OSB sheets in. This meant that at that point the studs needed to be doubled up, and I just needed to cut the top and bottom plate to separate the wall. If you've got the space to build your walls next to the build area and a few extra hands, then raising and lifting a short distance may be possible, but for me doing the front and back wall in parts kept things safer. With the back wall built, I framed the side walls. For these, with them being smaller, I was able to build them next to the dwarf wall. I also didn't attach the OSB before lifting. One, to save weight, and secondly, since the back wall should be square, as long as I ensure that it's plumb when attaching the side walls, they'll be pulled square without the need for the OSB sheets to guide it. Though I did still use an offcut to check that the stud placement where OSB sheets would share a stud later would still line up. Like the back wall, I added the end studs first. However, I needed to take into account the 2-degree slope of the roof, so my front stud is slightly taller and the top plate slightly longer. I also cut the tops of the studs at each end of the top plate at 2 degrees. Next, working out the spacing, similar to the back wall, I add the other studs, no backing block studs at the ends needed here. I cut the studs a little too long and then placed them where they needed to go. I can then mark their exact length with a pencil running along the top plate. I also ran a string line along the top and bottom plate to ensure when I added the studs in, I didn't inadvertently have the studs push these out and add a bow. Finally, I got to work on the front wall, very similar to the back wall, however with some extra work to take the window and door into account. For the window, I add cripple studs, trimmer studs, sill and header, which are two of my roof joists joined together. The doors are similar with the omission of the sill and trimmer studs. I got help from my dad for lifting the walls, then we just screwed the walls back together once they were in place where they needed to be. For the door, the base plate is kept there for now, but later I'll cut that away. All the wall pieces are moved into place and joined where needed. Once together, I double up the top plates, overlapping at the corners to the adjoining walls. To finish off, I added the OSB to the side walls. While I had my dad over, I also took advantage of his bigger miter saw to cut the roof joists ends at 2-degree angles and get them lifted up in place, but I'll go into the details on the roof in the next video. Alright, now let's go over the wall design choices regarding moisture control. Once complete, the room we've created will have moisture buildup due to a few things such as brewing any cups of tea or even breathing. When moisture in the air makes its way through insulation, it gets cooler and it condenses, similar to how you see condensation on windows as they're colder than the room's warm air. What we don't want to happen is this condensation building up in our walls on the timber, as over time that will lead to rot. Now in a low occupancy setting, which just means a room that's not lived in but only visited from time to time, the effects are smaller. It's not like I'll be doing my dishes, drying laundry and showering in the workshop, however the effects are still there. So to prevent this, we add a vapor barrier, and it's important to have this on the warm side of the insulation. This prevents moisture from getting through to the insulation and condensing on the cold side. However, it'll only minimize the moisture making its way through, so we add a breathable membrane to the outside, and that stops any water coming in but lets moisture escape. Now, because of the glue content in OSB, it means moisture can't make its way through the OSB, so we can essentially use that as our vapor barrier. This is why the OSB is on the inside face of our walls. If we were to have them on the outside, it would give us a vapor barrier on the cold side of the insulation, and so moisture would find it hard to escape and potentially condense within the walls. Lots of people seem to build a workshop and summer houses with the OSB on the outside, and in a low occupancy room or workshop setting, due to the lower moisture compared to in your house, this effect may be negligible, but for my build, we're going with the OSB on the inside. Next up, on the outside, after the breathable membrane, we leave an air gap. This is achieved by adding roofing battens and then attaching our cladding to that. The goal is to have a channel of air from the bottom to the top that can draw out any moisture that ends up back there. The dwarf wall at the bottom and small gap at the top lets this air through, and the effect of the heat of the day will warm the air back there, making it rise, pulling in more air from the bottom, exaggerating the effect, and circulating fresh air behind the cladding. When you add the battens, make sure to leave channels for airflow upwards, which needs some extra gaps around things like windows. And if you're adding vertical cladding, you'll need to double batten. Another bonus here is OSB on the inside will give better bite to screws when attaching things to the walls compared to just plasterboard, without needing to find the studs. That said, heavier items are still best screwed through where the studs are, so I marked where the studs are while building the wall, as once they're up, it's a lot harder to tell. So on the outside, I added the insulation between the framing and used a staple gun to add a breathable membrane. After this point, the walls were essentially weatherproof from rain, so I'll add the cladding a little later, though the specs for the membrane I've used say it shouldn't be left out the elements more than 3 months, as that's how long it's rated for to withstand the UV damage. So it won't be too long before I get the cladding up in another video. Right now the walls are only held down to the dwarf wall by their own weight. Now they're pretty heavy, so it's not likely they're going anywhere anytime soon, but later I tie these down with big galvanized L brackets to the concrete slab. A concrete bolt attaches to the slab, and then we attach to the walls with screws. No, I don't attach anything directly to the dwarf wall, as that would lead to us putting holes in the DPM or DPC, negating its effectiveness. Now for the costs. The materials used was 40 100 by 47mm 4.8 meter long lengths of rough sawn carcassing, 11 1220 by 2440mm 11mm thick OSB sheets, 10 galvanized L brackets at 210mm high, 10 80mm M10 concrete bolts, 5 by 1 meter breathable membrane, 6 rolls of 100mm acoustic insulation coming in at around 32 meters squared, 500 100mm screws, and 2.5 kilos of galvanized clout nails. That makes the wall costs come to £1,227, with a running total cost thus far of £4,051. In the next one, I get on the roof and get the windows and doors in to have everything weather tight.